Recording. Okay, so today is the day that we're gonna finish. Okay, so what's today's goal? I already talked about this with Maria. We're gonna finish the example the plus example we were running before, and after that, we're gonna try to run all the examples that we had before. And if all of they ran successfully, we are done for today. That's the goal.
So the goal is basically to run tough. That's it.
Yeah, we want to be able to run all the examples that the previous Karuta had.
Are all the old examples correct? Because I think we started changing freely a couple of them. So
No, they may have to be rewritten because of how we did with plus, right? Plus had to be rewritten to be able to change what is an input and what is an output. We may have to do those
Um,
messaging, but the program should be returning the same thing.
yeah, because Kangren, unlike Prolog, actually does not enforce um, top to bottom deduction order, right?
oh, I see.
So
Yeah,
yeah, you have to be a bit
But
more careful.
shouldn't we at least revisit the examples to see if we aren't
let's do that after the plus works. Right now I want to make the
okay?
plus work.
You're just excited and you can't contain it.
Exactly.
That's
I
fair.
want to see the 3 plus 4 equals 7.
That's
Uh,
fair.
so let's go to the compiler and let's actually add the exports. So my understanding is that each predicate will become a function, right, Marinho?
Each predicate will become a function on the beam, yes.
So that means what we need to export is actually the predicate name and its arity.
Yeah,
Compiler
exactly.
time. Did you pull?
I did.
Okay, let's go to the compiler then.
Okay, so it's in lib compiler, right?
Yeah. So whatever we are doing the compilation that we did last time, whatever that happens, before that, we have to do like compile exports, probably.
Probably.
Yeah, line 100.
Right. I
It's before
think
line 100, I believe.
clauses compile single body and then disjunction. I don't think this is quite it actually, is
Yeah,
it?
no, I meant before doing that, we need to compile the exports.
Oh yeah, this is compile declaration bodies. Okay, so this takes a list of this takes a list of declarations. Each one is one body of the predicate. We can just I suppose we could just extract the name and arity and add an export. You can have multiple export clauses in an Erlang program, right?
Yeah. Oh wait, I
Actually,
actually answered that without thinking. You want to have multiple exports instead
yeah,
of having a single one.
mostly because that's easier. But if it's not possible, then we shouldn't do that because it's not gonna work.
Exports in Erlang.
You can have multiple experts, but I think the first one is the one. I think the other is just for aliasing, if I'm not mistaken.
Wait, so you can't do something like this, right? Like have two different
Yes, you
export
can.
lists. You can.
Yeah. I mean, I did it and it works.
Oh, okay, so then you can.
I did it by mistake though, so and it worked. So
I did it by mistake, but it worked. Awesome.
let me
Oh
check
well,
it.
in that case,
For each clause, we just provide you an export, right?
no, it's for each multi-declaration actually.
Ah, you're right. It's for each multi declaration. Oh, okay. So grab the arity on the 106.
Single function
I see.
declaration.
So what people usually do apparently is that they group semantically the functions that they want to export in like export groups.
Ah, okay.
Well, that's convenient for us because we can just make an export per predicate.
Yep. Okay, so before returning the compiler with the new output, let's create the exports to pre-append to the output before adding the declaration compiled.
I mean, we can put the exports anywhere. It doesn't matter because
But I would like to keep them before the definitions just to be easier to read because we're gonna have to. I imagine we're gonna have to debug these in the Erlang AST at some point. We're gonna have bugs of that nature that require us to read the AST. And having the
well,
exports in a very well-defined place, it helps.
in that case, how about each predicate has its export immediately preceding it? Like
That's good enough.
we emit, yeah, we emit code like this, for instance.
Yeah,
So
that's very good enough.
export predicate, then we do export, I don't know, whatever, and then we do whatever, like this,
Yeah, I
basically.
think that's very good enough.
Okay. Well, in that case, I guess we can just we do have an export here, don't we? Yeah, we do
Export.
actually.
There it is. But you need to pass clauses. I don't know what clauses are in this case. You don't have. Do you have a list?
Um,
Yeah, go there. Export attribute.
just a list of. Hmm. Oh yeah, no, this is just a list of function names and narratives,
Oh,
basically.
perfect. So let's just use that.
Okay, so
Let's do a let before returning the compiler. I think that's going to be more readable. So let export
let export equals.
beam.builder.export attribute export, and now you pass a list of tuples, right? So list, it's always going to be a singleton, right? Because we are going to do for each multi-declaration, and then it's namef and arity in, and then you need to pre-append the export.
It kind of sucks that this thing takes the.
Can you
This
do a
thing takes the
concat?
collection first.
Yeah, but can you do a concat instead of a snock, and then
Uh,
we make
I mean,
the
yeah,
export and
that
declaration in a list, or finger
I mean
tree, I
that
should say.
works. Um, I
Append.
think this
Yeah.
append, and then we do.
What's the type?
It takes two finger trees, so we need to do ft dot
Off list maybe,
of list,
and then you make the list like that.
and then we just add the exports here.
There we go. This should be enough, right?
Theoretically, yeah.
Okay, so now let's run it. Let's actually run it to see what the fuck happens.
All right, so we
So
have to do Dune,
Dune
exec,
exec karuta
Karuta,
dash dash compile, and
com,
then
I can
you
type
make, yeah, and then the path for the plus.
examples plus
That's it.
KRT.
That's it.
Uh, where is this going to spit out the output?
Right now it should spit out in, using the print, but it should also spit out in the current directory a plus.beam file.
Okay, let me just remove this just to make sure I have the right file there.
There it is.
Okay, plus beam.
Now you go to the REPL yourself.
Okay, we have the export, so it looks to have worked.
Okay, but we should also. Can you try? No, no, no. Don't do the. Oh yeah, we need to have the runtime. Yeah, no, never mind. Now you do L,
So,
L plus. That's it. It didn't work.
I think we have to do plus dot beam, no?
I don't think so. I think it understands the things.
No file.
Yeah, I think it's just a load.
Oh, this is the wrong name actually. It's plus with a Z.
No, it isn't. Because you are probably using plus.beam, the plus being the
Oh,
name of the original Karuta file.
Oh, yeah, no, you are correct.
How to load a Beam file. I'm pretty sure it's load. And the error message is a little bit. We should take a look on the error message because the error message makes sense if we made a mistake in the.
Load or reload a module. Load or reload a module.
Oh, we don't have a module.
Well, we do. It's the plus.beam.
No, but that's not defined in the file, right? There's no module directive in the compiled Beam file, is it?
There should be. If there isn't, that's a mistake.
I think there
Let
is
me
in the man.
look. Let me look at this. Where is it?
Oh no, there is. Oh, that's the problem. It's not finding the module examples slash plus.
Okay, so actually, okay, we're kind of assuming that we should take the base name of the module, maybe.
Yeah, probably. You have to manipulate the file path. Yeah, it's with C. Well, no. Yeah, L. L should be the one to do the beam thing. Yeah, we need to is extract the name of the file.
Uh, where are we calling this? Actually, being, oh, this is easier, right?
No, but is this the
Compile
one putting
file path.
the module? I don't think this is the one putting the module, man. I think we are doing that ourselves somewhere else.
Forms, blah blah blah, concat list map attributes to string forms.
Yeah, we're definitely not doing this in here. Can you check the beginning of compilation, maybe? Beginning of compilation? Yeah.
Hmm, what the heck? This is not called anywhere.
This is no, this is called. I think your LSP is not working because this is called in some place there. Well, it compiles. If it was not being used, OCaml would not allow us to keep it.
Okay, that means we're
I think it's in the
taking.
compiler, man, that we are compiling the module as well, putting the module there.
You mean here?
Yeah. No, but this is already receiving a list of clauses. The module is already being lost at that point. So go to the main.ml.
Main.ml. Ah, it's the executor compile that gets called first. File path parse preprocess. Then we call compile prime, which takes the compiler.
Yeah, and this is already just calling the compile from within the compiler. Yeah, this is not it. Somebody else is doing that. Can you go back to main.ml?
Main.ml.
Oh,
And then we call
wait.
to world compile from here.
Yeah, but it is still not clear to me who's compiling the module. Check extension, compile the forms, transform to a finger tree, and then you may run that. You may.
It's probably this guy.
We don't know
Compile
where
prime.
compiling the module. That's so funny.
And
Yeah,
we
so it
call
must be in
compiler
compile, man. It must be compile.
compile.
Oh, there it is. Can you go up? I think we're just blind. Uh, Declare. Oh, it's in initialization. That's where it is. Initialization of the compiler, man. I remember. I remember that. That was like the first real session doing the compilation.
Oh yeah. That means then that
Yeah, line
uh,
35 needs to be a little bit more nuanced. Just chopping the extension is not enough.
do we have file name? Oops. Do we have file name? Oh, we do actually. Okay.
Let me read the documentation of that. You can
I'm
run.
expecting that.
You can run in the
Yeah,
meantime.
I'm expecting this to work like the Unix command.
Yeah, it is.
Okay.
Okay, now the module is just plus. Try to go to the repo and load move the generated, right? Because you just recompiled, so move the plus.bin to the runtime folder, and then go in there and let's try to see if it works.
Okay.
Okay,
Can I do
plus.
can I do fun? Okay, we have a function apparently.
And
And
it's 3 argument function.
can we call it is the question.
Wait, but this is a
Um,
3 argument function, so how do we plan on calling it?
oh, that's because each predicate takes its arguments, same number of arguments as
The
the
predicate?
Karuta predicate, but it actually returns another function which takes the state and computes the stream of possible states um, that match the predicate, that satisfy the predicate, I should say.
Yeah, but in this case, okay, I'm still not clear to me how do you call it then from the REPL.
Do you
Uh,
need to feed argument? Like, what are the the arguments? I suppose they're normal Erlang variables, right?
Yes.
So when you call,
oh, I
does it
forgot.
actually?
You need to load Karuta.
Load. Actually, I need to
Confusion.
compile temp
Yes, Magetta, you're right.
Karuta.
But then, what is the third argument?
Yeah, so here's
Like,
the
I
thing.
can
It
understand true,
is,
but
yeah, it is. It's not a one-to-one mapping in the sense that it has the same arity as the predicate version, but it's returning you
Mhm.
a function, and you need to pass logical variables to it. So you see what
Oh, so you
Marinho is
need to declare
pasting here?
logical variables
Yeah,
and
and to that you
I see.
use the. You see, okay, so let me
Hmm.
explain what's going on. This program that Marinho is trying to run. Let's start from inside. You see that you're doing plus column plus. That is the
Yeah.
one that you compiled. It receives 3 things: logical variables or
Hmm.
terms. In this case, we want the left and the right hand side as logical variables, and we want to say that the result is this term, which is successor, successor, successor of 0. Um, to initialize the logic variables for querying, we have a helper called query variable, which gives us bindings to have logic variables. So that's the LHS and RHS.
I see. So
To
the key is that you have to embed it with the runtime, right? You call it's
Yes,
not just
yes. So
a
our
first
REPL
class
cannot just
Erlang
be
function.
the Erlang REPL because
Is
in
there
order
any
to
way in which we could embed it just to be a callable object from Erlang? We would need to do a wrapper, right? Somehow.
yeah, we're gonna have to give you special like helpers that does all these manipulations. I don't know how we're gonna do that yet, but maybe that's possible. Did it work, Marinho?
Well, I have the modules, the runtime modules loaded, but apparently I got an error here.
No, yeah, but before it was complained that you don't have conjunction 3, right?
Conjunction tree.
Yeah, you see there exception error, undefined function, conj 3.
We really don't. There's only conj 1 and conj 2.
So I guess that means that our plus is wrong, right? That's what it means.
Let's see. Remote atom, blah blah blah. Actually, let me copy this. This is probably easier to check.
Okay, so we are
Uh,
doing a conj somewhere that is assuming the existence of 3 arguments.
Okay, we're calling conj in two places. Call Karuta. I think we forgot to wrap something in a list somewhere.
I
Let me
find that very
see.
hard to believe because we have specifically. Oh no, that could be the case because we just allowed to be a single generic expression, right? We didn't just make it a function.
Compile declaration bodies. Where is conj? Okay, there's this place. List map make function. Conj takes an expression list. This takes a list of goals.
Yeah.
Yeah, this is the problem actually. And these are all wrong, in fact. Are all of them wrong? Not really. These two are
Why are
okay.
they wrong?
Because we need to wrap this in a list, actually.
They are already a list.
No, I mean we need to wrap them in another list because here's the problem, okay? If we take a list of goals and we pass this to this call with module directly, that's effectively calling this or conj with however many goals as arguments.
Yeah, that's what I understand. So that's why you want to wrap it in another list.
Exactly, yeah.
But does it need to be a list in this case then, as the argument for Gis and conj? Oh, it's because in
Um,
that case you're gonna make it a single argument instead of many.
yeah, it's a single argument which is a list, which is what the this one and conj one expect.
Okay, so
So
do you plan on doing that?
in order to fix that, we need to. It takes a list of expressions, but we need to turn it into a single expression which represents a list. So actually, what we need to do
There must be
is
a way to express a list as an
there is
expression in.
there is. If we go to builder, um, lit atom var string tuple.
We don't have
Here
a list in here. Oh, we
we
do
do.
have a list expression. Okay, so just call those helpers in here.
Oops.
What does it take as argument of the? What's the argument type?
There we go.
Damn. Okay, this is actually pretty handy that we just have to change the helper. The original code is kept the same.
This.
Awesome.
Let me just recompile. Move this there. Reload plus. And try again.
Yeah. Try again.
There we go.
There we go. Mageta, look at that. Where's the halo? Where is the halo, Mageta?
Wait. I need to find it. There we go.
Okay, so it actually worked. We should make a helper function for that, Marinho.
Yeah, I think it's.
Look at that.
But if it's generic, to generate as many.
Um, it isn't.
That looks like a.
It isn't.
Oh, that looks like a monad though. You just need to bind an arbitrary amount of variables and then just compose
No,
all
but
of
that
them in a.
depends on what the user wants. So in the case of you asking the query, oh, I have the result, give me all the potential candidates for inputs, that is how you write that. But let's suppose that you want a different query. You want to give one input and in the result, and you want the other input.
So you're
um,
talking about the combinations of the
Exactly. That
arity.
changes. That in this case is not going to change much, but that potentially changes how you write how many calls with freshes you're going to need.
well, what we can do is do something like this, I suppose.
Oh, we can give like a list. Okay, that's a rough implementation, but I think that would solve it. You pass a list with like booleans saying what are the variables that you want fresh, and then that's an option.
Yeah, but that's gonna piss the head out of Marinho, man.
Why do you think I suggested booleans? It could be anything.
I mean, theoretically, we can do something like this, right? Fun. Actually, let me just copy this. That's easier. Up to here, actually. Like, if we do something like this, right, we can just goal. We can just parameterize over the goal here. And that should make our lives slightly easier, at least, because then we can just do...
A bunch of calls refreshed ourselves.
If I start stuttering, it's because I'm using all my processes to build C. So
Okay.
Okay.
Okay, actually,
That's good.
for recording purposes, we should explain why this is a success. Because on the right top corner terminal, we have 0 plus 4, 1 plus 3, 2 plus 2, 3 plus 1, 4 plus 0, which are all the possible combinations of addition in naturals that give us the number 4. That's why it's a success.
Yeah, and then we can get rid of all of this. This goes here, this goes here. And we don't need these.
Yeah, but that's still not very convenient. But I think in order to make it more convenient, we would have to make like a DSLL or something.
A DSL, you say.
Yeah, DSL.
Um, I mean, you're supposed to... I guess technically we could... like, we could make something like fresh and the run functions from minikanden. But they won't be as nice as they would be in Lisp because we don't have macros, so we would have to work around that because fresh is a binding form. So
Yeah, but that's the thing, Marinho. Magetta wants, like, his wet dream is being able to just use the Erlang REPL as the Karuta REPL.
not really. I mean, I think it's convenient, but I think there are very awful limitations on relying on that, right? So we maybe would just want to have a first class REPL returning something else.
Yeah, we're gonna have. I think we should write our own. But I think we can make some hacks. For example, we could make our REPL is just an Erlang process that we pre-process your stuff and then just dispatches to the real one. That's gonna give you very bad error messages, but at least that's usable. Okay, so now let's compile another program. Let's go to the examples. Let's check what's the second most trivial program.
okay, that's plus. Actually, um, oh yeah, this is the other thing that I did on Saturday actually.
Wait, this. But what is
It's merge
this?
start. It's
Oh, this
merge
is merge
start.
sort in Karuta.
Yeah.
Okay, but this is. I don't think this is the second most
It,
simplest.
no, it isn't. It isn't. It's just I
Let's
just
check
saw
the
this and I
minus. I
remembered.
think the minus is. Okay, this mandates us to implement negation and plus with s as built-ins. Let's do that.
Uh, actually, you know what could make our lives easier?
What?
We can actually generate that run all call here with the call refresh if we compile the query.
Oh yeah, we actually okay. We should compile the query in fact before doing anything else, right? Because then we can actually don't have to do this manual process every time. We just compile the query.
Yeah.
Let's do that.
Let's do that.
So it's in the compiler. Probably there is a pattern match in the query doing nothing.
This.
Yeah.
It is this, in fact. What's the
Okay, we
type of
have to
this? Is a
remember, Marinho, that this is a pre-processed query. So the query has an empty name.
The query has an empty name. That is true.
So we have to keep that in mind. Can you do that in the Erlang AST?
You can actually.
Okay, so never mind. We can just keep going then.
Uh, Okay, so what if we just if we try to compile minus, what do we get? What do we get minus?
Oh,
We get a core dump, apparently.
yeah, we it cannot it could not generate the beam. Oh, it's because this is assuming that this has an assumption that plus exists, but it doesn't.
But it
Awesome.
doesn't.
You know what this means? This means that you have to compile the whole prelude.
We need to implement these two things as primitives, I guess.
Yeah. Wait,
Uh,
but what are we going to do first? Compile the query or do the negation pluses built-ins?
I mean, the
I think
built-in
having the
shouldn't be.
query, I think having the query should be first because we are kind of like halfway through. We cannot
Okay,
ask a question.
let's do this then. Okay, let's just do this, and then we have a query here, and we don't have to worry about the built-ins, right?
Yeah, exactly. Yeah, but this is well, this will compile probably. Oh, it didn't actually. Interesting. What's the problem? Attribute export after function definitions. Wait. So that means you
Wait.
cannot do what Magetta said.
Ah, okay. You have to have all of the exports before the function definitions, I guess. Which
That
is,
sucks ass.
yeah, that's kind of annoying. That's kind of annoying, not gonna
Kinda.
lie.
Okay, but this is a limitation on the AST level because Magetta said he did
It
and it
is.
worked.
Yeah, we can do a trick, okay? Let's do the trick. Let's. Do you wanna see the trick, Lemos?
Well, I was about to suggest having the exports list as the inside the compiler state, but what's your trick?
Here's the trick. Before we were just doing this snock here, right?
Sure.
Of the declaration.
Yeah.
The trick is
Now you're gonna make a tuple?
ft cons, and then we cons the export to the head of the program. What do you say?
This will
Uh,
make all the exports on the top. That's what you're saying.
yeah.
Okay. It still didn't work, but why didn't work? Can you go there? Can you go up? Variable out is unused. Variable wait, shadow it. What? I never seen that error before.
Hmm. Oh yeah, here's the query. But out is shadowed.
What the fuck that error means, man? Well, I guess it means that you are shadowing something and you cannot in Erlang. But how are we doing that?
Hmm. Well, let's look at the compiler outputs and find out.
Hmm.
Oh, we have a bunch of people tonight.
Yeah.
Yeah. And I
Okay,
miss
but
Tevo.
sorry, Magetta.
I said I miss Tevo.
Yeah. Um. Oh, do you have the formatter, Marin? We have a trick to use the formatter before. Can you do it again?
Well, what I had done earlier was basically just rp copy this dot, and this is pretty large, but that's not a problem because we have a text editor.
Imagine if you didn't.
Well, you don't, you use Emacs. It's a good operating system, don't get me wrong, but you know.
You know what I discovered?
Yeah.
Windows has its own terminal text editor called Edit, right? And it's phenomenal.
Magetta is turning to a Windows fanboy.
And turning into a man, I the more I look into the history and etc. of Windows, the more I become a Windows guy. But I'm not crazy, so don't worry, Lemus.
Okay,
I'll
so
not
where are we
break
doing
ranks.
shadowing?
It's here. We're not renaming the query arguments, apparently.
Ah, that makes perfect sense. Go to the preprocessor. Ooh, but that will
Preprocessor.
mess. Okay, we have to be careful because you're doing a trick, right? There's already a trick on the query because we created an artificial declaration for it, and we also have an artificial name for the predicate that we're asking the query without the bindings. So I think we need to rename after we do the first trick. Agree?
We need to rename after the first trick.
Yeah, the first trick is
Um,
adding the artificial declaration. The artificial declaration is using the original names of the query.
you are correct, I think.
Okay, so that means is no, it's down there. No, yes, it's here. This is the place. No,
Um,
go up. It's above where you were before. Yeah, here. This is the place. Query conjunction pattern matching. Line 122, we created the artificial declaration. Is it here or not?
it should be. Multi-declaration. We can just do this, though.
Sure.
Okay, what's the problem now? No module definition.
Oh, no, we cannot
Ah,
do that. We cannot do that because the original query is still using the old labels, right?
the original query is still using the old labels. I don't see the problem.
Ah, no, but we're gonna unify that anyway. No, never mind. I don't know what's the problem.
The original query is not being compiled, Lemos. That's a known issue right now. But I think I know the problem. The problem is my trick doesn't quite work because I'm missing something. Um, you see, by doing these cons, we're putting the exports before the file and module declarations, and that's a no-no. So,
Okay, so my original idea, put into the state of the compiler an output specific for exports that we keep accumulating, and then when we go to when we finish, we append the exports in we concat the two finger trees, putting the exports in the beginning.
we can do that. There's a less intrusive way of doing it, though, which is just add a new field.
Yeah, that's what I meant by adding to the compiler state. That's precisely what I meant. Don't forget to put in the type definition on line 30, by the way.
Line 30. Um, and then here, we grab the header as well. And we just do ft append header output.
What is the finger tree? What's the question? What is the finger tree for? Because finger trees are better lists, my friend.
Yeah, you can add and remove elements from both ends, and you have efficient concatenation and slicing. They are amazing.
Yeah. Which, by the way, Karuta should use those using lists just for syntax.
That would require us to implement finger trees in Erlang, which might be doable, but we won't be able to get the full benefits of them because Erlang does not have laziness, unfortunately.
I see. Okay, what happened now?
It
Did it work?
compiled.
Oh, it
No,
compiled?
no complaints. So um, theoretically, we just need to. Well, we have this. Now we just need to. What do we need to do? What do we need to do? We need to compile a decent entry point, I guess.
Yeah, you need to compile an entry point,
Um,
which is essentially the function that you did, right? The start, and then the calls with fresh.
I mean, just as a sanity check, let's run the new version of the code.
Don't forget to move it, yeah.
And now I should be able to do call with fresh x, query variable x. We don't need this. We don't need this. And we're gonna call plus this, and this is kind of cursed, but it is what it is.
I thought that would be allowed on the AST level. I didn't know you could do that in Erlang.
I mean, you can quote atoms, so why should this not work? I'm missing a parenthesis somewhere. Oh, here.
Empty.
Okay. What's the problem? What is the problem? Oh, this is negative, of course. This is not gonna work because those are not proper piano numbers. So let's fix that. Actually, let's just grab the
Piano
old
numbers.
example. Let's just grab the older example. Let's say uh, 4, which is successor of successor of successor of successor of 0
What did you
plus
say,
2.
Magata?
I said, why not piano numbers?
Of course.
Because we prefer forte numbers, actually.
Forte. Yeah, yeah, Marinho got it. Thank you, Marinho. That's why I like Marinho, man. He gets references.
No, he make references nobody understands. He's even better.
Yes.
There we go. 4 plus 2 is 6, apparently.
Yeah. Okay, so that what did we just fix? We fixed.
We had minus 4 and 2,
No,
but we need to do
no.
piano
Before
numbers
that,
here.
no, before that, we we fixed the export list thing. Okay.
Um, I
Hmm.
I'm thinking if hmm hmm
Wait a moment. We compiled the query that well we you in your trick you assumed it would be compiled and it was. Oh no, but this temp run all needs to be generated by the query as well, right?
yeah, what we have is the preprocessor splits the query into an entry point, which we're not generating yet, and a predicate that the entry point immediately calls, which we do have. It's this empty name one.
Yeah, that's what the preprocessor does because of the query conjunction mechanism, right?
Yeah.
That's how we are
Uh,
unifying, like putting the conjunction between them.
yeah. Now we need to look at the query compilation to basically generate this, essentially. And we immediately have a problem because now we need to invent a name for this thing.
What? Which thing? The thing that you highlighted?
The entry point, yeah. Because here's the issue. We're using the empty name for the query predicate, right?
Yeah.
But we need another name for this thing here, and it must be different from this.
Ah, because we're gonna generate that for you as well.
Yeah,
Easy. Just make empty name with a different arity.
that doesn't work in general
Fine with me.
because um, the arities of those two things will always be the same. Actually, that's not quite true. The
That's not
arity of
quite
this
true.
thing could be zero, in fact. It could be zero
Tevo
if
gave the
we're
best solution. Just put two spaces. Just put a space between them.
That actually doesn't work because that's a valid predicate name
Yeah,
on Karuta.
that's a valid predicate name in Karuta.
Unless we forbid that one as well, then we have two names that are not allowed, the empty one and the single space.
I'm more in favor of my idea. Just use the empty one, but change the arity. And it doesn't
Okay.
matter if it's gonna be useful or
So
not.
an empty with more than the empty has more than one. How's
The
the empty right now? It's used for
No,
lists, I
the
think, right?
empty. Okay, so let me explain. So let's suppose that you have a query. Marinho, you can continue doing what you're doing. I'm gonna explain to Mageta. So let's say that you have this, Mageta. I'm typing on the chat.
Okay.
Let's say that you have this. In
Yeah.
order to, when we pre-process that conjunction query, what we do in fact is this.
Oh, right. You're wrapping in a single. Yeah, I think
Yes,
I recall.
exactly.
But that creates a new problem, Lemus. What if
Tell
we
me,
make a query with no variables?
what's the problem?
Now we have now we have a name collision because the query predicate will be empty name with zero arguments, and the entry point also wants to be empty name with no arguments.
Oh, you thought of me of putting actually the zero. I was actually proposing arity plus one
Arity plus one, why?
because that is guaranteed to never ever have a collision because arity is going to be the arity of the query after being pre-processed, and plus one because the name is empty, nobody can pick it. It's always going to be us.
But then what do we pass as the dummy
A
arguments?
bunch of news.
But Erlang doesn't have news, it has the empty list only.
No, it has a bunch of news as atoms. I'm gonna write here to the just to for Tevo and Lucas and Natan because Mageta got it, but I just
Yeah,
remember that Mageta has
that sounds
advantage.
fair. I mean, I can't evaluate the consequences though, but
Mm,
Okay, I'm gonna do it just to get this working, but I want to be on record saying that this is cursed.
wait, what I just said?
Yeah.
Yeah, I allow you to do that.
would that would just be on the compiler, right? So there's no
Yes.
artifact of that at the generated bean file. So
Yeah. So just explanation for
we would
everybody.
just one
That
thing. We might have a problem with that if we want to ever do macros, no?
If we want to ever do
Yeah, because
macros.
they're basically generating another predicate, like with
Marinho
another
not
arity.
allowed to have
No,
macros.
no, because even if we did have macros, you are not allowed to define a predicate with the empty name.
Hmm.
Okay.
Yeah,
Mhm.
the premise, the hypothesis is that we are forbidding you from using the empty name. Anyway, wait, if you're forbidding the people from using the empty name, Marinho, why can't we just use zero? Name F, empty, and arity zero.
Because the query may have zero variables, in
Ah,
which
okay, yeah,
case.
that's true, that's true. No, never mind, that was stupid. Anyway, so Lucas, Nathan, and Tevo. The query, when you have a conjunction of a query with a conjunction, which is the comma, we translate that to this. So that's why the empty name matters. So just for you two guys to also to be on the same page. Okay, so are you gonna do what I said? Arity plus one?
Yep, just to get this
Awesome.
wall going. Or we can make that nicer later. I just want to have a proper, nice-ish entry point, so I don't have to copy.
You know that there's no answer to this problem, right? Aside from making another special name.
Um, there's no answer to this problem.
Aside from creating a special name, right? If we don't want to introduce another forbidden name.
Aside from creating a special name, yes.
Yeah, so we're never gonna change it. So I'm telling you right now, Mari.
I mean, we can call it main. A lot of languages do that. Is that good or not? I don't know.
Mm. Now the answer is I don't know.
I mean, it's
Good.
better because we don't have to pass a bunch of dummy arguments to call main, but it's worse because now we have a second reserved name, which I
Actually,
don't
you don't need
like.
to pass a bunch of arguments, right? You can just put wild cards for the extra ones.
You need to pass them at the Erlang level, though, if you want
Mm-hmm.
to call the query.
Yeah, but we're gonna fold with a bunch of wild cards, right? Like the list will have a bunch of wild cards in the Erlang level.
I mean, um,
We don't have to pass anything to them. Couldn't you preserve a prefix like C implementations? Well, we could. Like everything is possible in a sense.
we're going to have to probably we're going to have to reserve a module name at some point. But that doesn't work because we can have a query per module. Never mind.
Yeah, but for now, let's just do the dummy way.
Let's just do the dummy way. Theoretically, this should be this query should just have a bunch of variables as the arguments, right?
Yeah, yeah. Uh,
So okay,
yeah, but I
here's what
must say that
we.
using the zero was more clever if it wasn't for the gotcha.
Yeah, because you can have a query to just check if something works,
Yeah,
but doesn't bind any variables. That will generate zero arguments predicate,
yeah,
which is
yeah.
which is a
Very sad.
no-no.
Very sad.
Let actually
I'm having a deja vu because I'm thinking we already edited this exact part of the code somewhere in another session.
No, we did. That portion of the code that he just
I
changed
mean, we
was
wrote that at some point, but what was the point of it? I don't know.
no. When Marinho goes back because he's checking some types, when he goes back, the pattern match immediately above it, Mageta, was the one that I was changing on Friday.
Oh, okay. So
We
that's
are not
where the
touching
number
the
comes
query.
from.
We were touching on Friday the multi-declaration.
Hmm.
Okay,
mm,
query time.
okay. So what do we do? We
We need to create a function with the name fname, right? The arity of the function will be plus arity plus one, and
yeah we do. Let me just copy this.
yeah,
Extract variables from elements. Actually, we don't need to do any of this. Because args is always going to be an empty list here.
wait, what? Args for the function, you mean?
It is going to be an empty list. Actually, no, we need to generate the
Yeah,
dummy names.
yeah. No. The dummy names are already being done, right? That's what the preprocessor did it for us. I'm assuming.
Actually, do we need the dummy names? We do because of shadowing. Never mind.
Yeah, but that's not gonna be an empty
Um,
list there.
no, it won't.
Yeah.
But this is not going to be this either because we need to I guess technically we can just use a bunch of discards. Builder, do we have that easily? We do, in fact.
Wait. What are we What are we compiling? You're compiling the declaration that we created for the query. Is that no? We're not doing that. We grab the query,
No,
which is
this
a functor, a single functor with the name f equals to empty, and we have the variables that the user is interested in. We rename them,
who
right? And now we are making the function out of that. Is that what you're doing?
Okay, we have the yeah, we basically have to compile this thing essentially because the actual predicate that implements the query is already being emitted, right?
Yeah, that's already being done, kind of like a side effect. Well, it's being done because it's a declaration. Declarations are being done already.
Yeah. So what we need, in fact,
Oh, we need to
is
generate the function that we're gonna call in the REPL. That's what we're doing right now.
yeah, exactly.
Ah, I see.
Let's do this for now, just so the formatter works. Okay, so we need to do a list which has a length arity plus 1, right?
Yeah.
So we don't have a collision. Arity plus 1, so we don't have a collision. Um, Actually, I had an idea, but it's a terrible idea. Let's not do that. So
No, no,
arity
no.
plus 1.
What's the terrible idea?
I was gonna say, we can just special case this so that if we are emitting a query implementation, so empty name, that has arity 0, we make it have arity 1 with a dummy argument so we can free up the arity 0 for the entry point in all cases.
And
But
this is
that,
getting more markers.
yeah, no, that's cursed. Yeah, that's probably more cursed than what we're doing here.
I think it's on the same level, like on par.
Do we have a list repeat or something to that effect that takes a number and a value and makes a list of
I
that
think
value
it's
with
either
that length?
repeat or range. Let me check.
Print,
Oh, I
combine,
am doing no, no, no. I
compare.
am doing. Oh, it's a string.repeat that I used in the for the error messages. I didn't use lists. I have a bad feeling about this.
Init, that's what we want.
Are
Init,
you sure?
arity plus 1, and
You have to pass a function though.
builder pattern dot wildcard.
I think it's discard that you called it.
Oh, it's
Oh,
pattern
pattern wildcard.
wildcard. Okay, so args. Okay, what's the problem?
Put parentheses on the lambda, man.
Oh, this needs to be bean.builder.
Oh,
Give it back.
Tevo found a typo in the miniCunning module. I forgot an N. We can fix that later. Thank
You
you,
are
Tevo.
you are insulting the readers of the module name by calling them Karens.
Man, I think we have a const function. Can you try fun.const instead of a lambda with empty binding? Thank you. Remember, we also have the side quest of pissing off ML people.
Let's piss them off more then.
You have an extra parenthesis now, my friend. 132. Yeah, there we go.
But this is a pattern. Is that okay? Function declaration, name arity clauses.
Yeah, maybe you have to
This takes a
transform
li-
the pattern to a clause. I think there is a way to do that actually.
oh, this
It,
takes a list of strings always.
yeah, but a clause is just a bunch of can have a bunch of patterns, right? So I think we just have to wrap those around.
Nah, let's just do this actually.
Uh,
But then that means we need to fix something else elsewhere.
yeah, but that
Uh,
that doesn't matter. This is a compiled language. It's gonna tell us. It's fine. Thank you.
112. Yeah. What did we have before? Yeah, this.
Oh, you want to be able to reuse it down there. I see. You need to put beam.builder. And look at that, man. We should make some open sometimes.
Uh, okay, so we have the arguments and the body, the body is going to be.
It needs to be that, right? Run all. Maybe we also need to put the run all as a primitive in the Karuta runtime.
We need to do something kind of similar to what we did this here, actually. And we shouldn't do this particular one all, but I guess it would be nice to have that. So let's do. What do we do?
Go to
Let's
the temp
do
and move it
runtime.
to the Karuta.
Mm, you know what we can do?
Tell me about it.
Okay, this is kind of assuming that we're gonna do all the variable bindings and construct the proper query in the goal. But
I don't think we should assume that.
why not? We control the code generation.
Because it's more code that we need to generate. I just want to generate the minimum amount of code that gives us flexibility that we need. Do we need to have these generated by ourselves, or can this just be done by the Erlang runtime?
Because I was thinking, if we don't mind the runtime doing it, we could just take a list of names and then do the. I guess we can't really do this because we need to generate a bunch of lambdas. Hmm. Actually, do we? Do we? We could theoretically make a function that takes a list of atoms and add them to the query and makes a bunch of fresh variables for them and returns the new state in the list of corresponding logic variables for those names, and then we can just pass that to the we can just pass that down to the goal. Or I guess it would be a goal constructor at that point.
Yeah, I'm in favor of putting into the code generation of that we are doing in OCaml everything that we have to have granular control. Everything that we in the future we may want to interject something very like precisely, then we put in the OCaml side. If it's something that's gonna be there forever, like the disjunction and conjunction, then we put it in Erlang.
Mm, let's just generate this in OCaml then, because here's the thing. We may not... Actually, even this is kind of opinionated because there's this take call here. We should have a proper string map. Actually, let's do that. That's not too hard to do. String map takes an f, takes a string, and then we shouldn't pull actually. Let's copy this for now. Down here. So if this is empty, we return empty. And actually this needs to be ignored.
Wait, we are replacing pool with stream map?
No, we're going to have a separate function because they serve different cases, right? Pull is when you have a lazy stream
Yeah.
and you want to grab the head of the stream if it exists. This string map is to replace this list map that we're going to use to actually grab the query mappings. But we actually don't want to force this with a take all inside of this run all function. So we're going to do a string map here, you see?
Yeah,
That's the idea.
I see.
String map. Let's just do some nice structural recursion. And then string map. When is function, what is integer? Function. And then in this case, actually, what we need to do is make a new function so it stays lazy. And inside of that, we actually do string map over f, and we call the string to force it. Yeah, this should work, I think.
Cool.
So that means actually we can just do string map here. We don't need this qualified. We don't need this qualified.
The
And in
take all also
fact,
doesn't need to be qualified.
this can go away, which means this can just be in one line now.
Okay, so run all just does a string map, which essentially iterates the
Hmm.
function that you pass to it as it moves forward until it exhausts the list. Oh, so this is the opposite of take all. Take all was kind of like strict. You made a lazy version.
Let's call this run lazy, actually. Let's not reuse a name that means something else in minikernelling.
That's okay.
This can go away. And of course, we need to We need to export run lazy of one argument. Do we want to export the string map as well? I think we do, right?
Well, if we're gonna have to use it in the OCaml, we're gonna call it from the OCaml. I think we have to. We not really have a choice.
Hmm.
If we're not gonna use it in the OCaml, we don't need to.
Let's not export it for now. Let's just keep it private because we don't need it right now. We may need it later, but then we can just add it to the export
Okay, so
list.
your plan is in the OCaml to generate a call to run lazy.
Yeah, basically.
But what is the benefit of running it lazily in comparison to strictly?
The benefit is that if we have infinitely many different results, potentially, we don't try to force all of them and go into an
Ah,
infinite
like
loop
what
that
Prolog
eventually exhausts,
does.
yeah, all memory.
I see. Makes sense. So we just have to create the goal in OCaml now,
We just have to create this goal in OCaml now.
which is
And
gonna
this is
be
where
the
we,
one that we were creating before.
yeah, we basically need to do a call with fresh and a query variable for each variable in the query.
And putting a wild card at on the +1, I guess.
Um, we can ignore the +1 because here's what we have to do. Okay, we have to make call with fresh for each variable that the query exports, and we need to register that variable as a query variable so that the dref query knows to pull it from the
Yes,
state.
makes sense.
Um, and then we need to call the actual query implementation, which is empty name with arity without the +1, right?
What we're gonna
And
put
then
on the middle argument there?
what do you mean the middle argument?
Because the capital X is gonna be the variable that we already have on hand. But what about the atom that comes in the middle there?
We can just reuse this, but just quote it, I guess.
Sure, why not? Another question.
Um, okay.
On the point of where we are in the compiler, we don't have the names anymore, right? We only have the artificial names.
We
Is
don't
that right?
have the... No, we should have the names, actually. They should still be in the... In the args. Um, Here, the elements, actually.
We're gonna use. Okay, so we need to extract the variables out of the elements then,
Yeah, we need to extract the variable names out of the elements.
which we already know how to do. It's just line 111. Nice.
Not even, actually, because this... actually, no, this is exactly it, in fact. You are correct.
Okay, let's just go then. We just need to create a bunch of calls with freshes in a fold, probably, and a bunch of query variables inside of the thing.
Yeah.
Let's extract the variables first.
Okay, let query args equals in. Let's just copy this then. And this is actually a list, right? Yeah, string list. So what we need to do is
We need to make a fold.
yeah, we need to do
Iterating on the variables, because each variable will create a call with fresh.
yeah, we need to do let's do the call to run lazy first because that's gonna be on the outside, right?
That's the outside, yes.
So how do I do this? Beam. Let's open beam in.
That's nice.
Builder. We should have a call. In fact, we need to do a. This needs to be from the runtime module, right? So this needs to be a call with module. Then
No,
we
no,
need to
no, no, no. We
do.
should not do that. You should go to the
Oh
to
wait, no. This takes.
no. This is an expression. You're right. But we are making helpers for this. Remember? We did the same with conj in the mini cutting micro cutting module. That's where this should live. Well, I guess we can make a Karuta.ml because it's not in micro cutting anymore. This is in. Oh no, is it? I guess it is, right? You just paste it in there, so it's okay. Run lazy, yeah. Run lazy, and now you pass the thing. You need to pass an expression, a goal in this case.
And now we need to pass a goal. We need. Yeah, we need to do a bunch of calls with fresh now. I'm pretty sure we're doing something similar to that already somewhere else. Where are we?
Make function.
Oh, it's here actually.
Okay, so there we go. This should maybe it should be a separate helper function. We're using it two times already.
This is a set.fold though. Is that a problem?
No, because the calls with fresh are just creating bindings for the inner thing. So it doesn't really matter which order you're doing the calls with freshes.
Ah, it's because this is a set, but we have a list, so actually we should be able to just do a list fold. Yeah, let's make a helper for that actually. Um, multi-declaration. Here. Let um, uh, let's just call it call with fresh. Why not? Call with fresh, and then what are we actually doing? We're extracting the variable. This is the expression that we're wrapping.
Yeah, this is the accumulator. The expression is the accumulator, and you're receiving a bunch of variable expressions that we are destructuring with the name v. That's it.
Ah, but we have to do something slightly different actually.
Why?
Because we need to wrap this twice. We need to also wrap it with the query variables. Is that a problem? I don't think it is
Wrap
actually.
it with the query variables.
Yeah, no, we can just do a pair of. We can just do two folds. That's not an issue.
Oh, I think I see what you mean. You mean like we need to do a fold to wrap the thing with call with freshes, but inside there we need to do another fold creating the query variables inside.
Yeah, and this is
AST
AST
dot
var.
variable. No, dot var, sorry.
Let's open beam in. Actually, maybe this should be. Ah, no, actually, it has the same
We
name.
have
Never
total
mind.
control over the initial accumulator, man. We just need to pass. Oh wait, this is gonna be the argument of the fold. What you just did is the folder function. I was actually thinking of putting the fold itself as in there, but that's okay.
Um, okay, something is okay here. Run lazy. List old right.
The initial accumulator should be the query variables, man. Should already be a fold, the initial accumulator of this one.
Yeah, we're going to do two folds.
Yeah.
The problem is this is kind of annoying. This takes the list last, right?
Yeah, this should be a fold left probably. No, 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 this is right. Fold, it comes the element first and then the accumulator. This is right.
Okay, it's the list here and then the accumulator. That's okay, so we're doing call with fresh. This should use the query args actually.
Yeah. And the initial accumulator should be the result of the other fold. We should make a separate. Yeah, we should make a separate function just for that. We probably need to do some sort of Dune build. This
I'm
expression has
back.
type string list, but an expression is expected to have of type ast.var list. Hello, Maget.
Oh, that's fairly easy.
I thought that for a second I thought that was our error message. I was going to be proud, but
Wait, no, no, not proud. But
disappointing almost.
no, but we are almost there for compiling the query.
Hmm. est.var. That's a record, right? I'm pretty sure
Yes, it is.
it is.
Oh, you probably need to put, yeah. No, no, no. You need to open the AST module there.
Let's query variable. This is going to take a name equals in. Okay, what's the problem?
You need to do let open AST. Yeah.
Okay, so what we need to do? We need to do this a fold right. So in fact, we need to take another argument. We need to take.
The accumulator comes next.
Oh yeah, and the accumulator. Let me just finish this big expression because this needs to be. This needs to be builder dot call. This doesn't need the module because it's in the same namespace and
Expression, and then expression list. Probably is an atom, and then the arguments.
and then the arguments and then the arguments. What are the arguments? The arguments should be query args, I think. This is a tag list.
Should be query args, yes.
Oh, but I need to
Run
be.
lazy, calls with fresh. And now we are doing the query variables as the initial accumulator for that.
Don't we have? Yeah, this is a list of expressions. So this can just be v, I guess. Var. Yeah.
Sure. Yeah, query variable needs to receive another argument, which is the accumulator. We can call this body, I believe.
Okay, what's the problem? Ack list blah 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 has type unit, which is up there, but it was expected to be of builder. Okay. Then. Okay, so this is the body,
Yeah.
right? What we need to do
Let's create
is
another lambda, right?
we need to make another lambda basically.
Yeah. So builder dot lambda, and then we need the name
Um,
as the first argument.
we need to
Probably
do
as
a
an atom.
call with module. Um,
We should make
actually,
a
what am I
helper.
doing?
Yeah, but we should
We
make a
should
helper. Yeah.
let query variable. Mm, hmm.
What's the problem?
Actually, is it okay to make this take just 2 arguments, even though the actual function takes 3? Because
Are we gonna need
we
the
kind
flexibility later?
no, we kind of want to have these two have the same name.
So only two then.
Var name and body. Actually, this is a goal.
Yeah. Oh, we also need the module name, right? Because that's coming from plus. We need a module name.
No, that's in the goal actually. So we need to
Oh,
do
we're
a
gonna
call with
create it
module
outside. Okay.
Karuta,
That's an
and
atom.
this needs to
Don't
be
forget.
an atom.
Sure. Query variable.
Query variable.
And now the list of arguments, right? So
And now the list of arguments.
we need
So
a variable first and then an atom. And then the
and
goal.
then we just the goal here.
Awesome. Man, it's so awesome that like the credit for this is all yours and Magita's because we can clearly look at the code in Erlang there and immediately tell how it's gonna write in OCaml there.
And in fact, we don't need this lambda anymore. Because this can just be this.
Are you sure? I'm not so sure, actually. And here's my argument
Unbound
on why.
value.
Oh, you swapped the wrong thing.
Oh yeah.
Here's my reason why. This function takes 3 arguments, no?
The primitive in Erlang does, but as far as code generation is concerned, we kind of wanted these two to be the same.
Oh, so this takes only 2 arguments. Okay, my bad. Okay, so this is a single full-blown declaration now.
Yeah, that's the declaration that we're going to emit, and we need to do compiler with output equals, and we just do this basically.
Okay, so let me read this to see if I understand. The first thing what are we doing? We are creating the declaration that represents the lazily running all the possible answers for your predicate, for your query, which because it was already pre-processed, it doesn't matter if it's conjunction or not. So the first thing we do on 135, we extract all the variables from the body of the generated declaration that we made in the preprocessor. So those are the elements. Then we do fun args, which is essentially creating a bunch of wildcards on arity plus 1. This is to make sure that you're not conflicting with anything else, because you cannot make predicates with empty names. Then you do single function declaration namef, fun args. So that's creating a function in Erlang with an empty name, with arity plus 1 wildcard arguments, which in the body has a run lazy that does arity calls with freshes, and after that, inside the calls with freshes, we're doing query variable, which is essentially what you have on the top right there, which is that lambda there with fun x blah blah blah. And we're doing that also arity times. Yeah, arity times. And then we are doing a call at the end. Why do we need the call on 144?
Because we need to actually call the goal with the arguments that we constructed using the calls with fresh.
But aren't we just defining it right now?
Defining it, what do you mean?
Ah, that's that plus there.
Yeah, it's this.
Yeah, but do we have the plus as the module name? I don't think we do.
We don't need it because this will be defined in the same module that the actual query, this thing is going to be.
Ah, I see, I see. Okay, does this compile something?
It does.
No, compiles in OCaml. I mean, is this generating stuff?
Um,
No. Okay. Let me
unbound
scroll up.
var to do. Oh
It's getting
yeah,
big. It's
I
getting
need to
big.
I need to fix that. Builder to do.
It's
Actually, it's
probably
not here.
industrializer at this point.
Hmm. Yeah, I don't think we have wildcards here yet. Let me fix that real quick. Actually,
Ah,
how does that get compiled? Um,
okay. So
um,
it's gonna be TMP column parse tree, and then you're parsing yourself.
this. Yeah, basically. Actually, this needs to be quoted, I think. There we go.
So
Yeah.
Uh,
function wildcard. There you go.
okay, so it's literally just a var, but the name is underscore.
Yeah.
Okay.
Man, we're gonna
Hmm.
really regret the day when we have to introduce location to these things. But okay.
Well, that day will be your day, Lemus.
Not no at all, man. I told you guys before, and during my absence, you guys decided to do it anyway.
Marinho's defense, he actually wanted to do it, but I said, ah, man, let's just do it
Oh,
without
so it's
it.
your fault. I see.
Yes, it is my fault.
Additionally, in my defense, I was not the one who defined the ASTs. It was Magetta.
No, but
That's
no,
true.
but in his defense, I told you it would be draft and we'd have to do some polishing of the corners.
Uh,
Great. Let's see what happens now. Of course. We have to export it, my man.
Amazing. Okay, let's do that.
Wait. So you try to call what? And the
No.
function
We
empty.
compiled. Okay, so this command, this subcommand of the CLI of Karuta, actually tries to invoke the REPL. Well, not in the REPL. Well,
Well,
we
something
actually
on the
do.
runtime, you mean?
Yeah, no, the REPL. When you do compile, I'm actually, in order to make your bin file for you, I am spawning a process that is
Oh, I
running
see.
Earl.
I
And then
remember that. That,
yeah,
that
and
was
then it
the
is
day.
attempting to load it. Well, load the compiled forms, right? So that blob up there. But it found a function that is not being exported.
Yeah, but I'm just curious about the empty function not being exported. Like it's on the same it's on the same module, no?
Yeah, but even if it's on the same module, you have to export it manually yourself.
But if you're just calling the top function, why would you?
That's a question for to the Erlang people, not to me.
Something's not right there.
Now it worked, because now Marinho is exporting the function. Okay, so that
Well, if it's
means
just an internal, man, this doesn't make sense. If it's an internally called function, it's fine, right? If you're not exporting it, like if you're using it inside of the same
no, you
module, that is.
no. Here's the thing: when you compile our beam our AST, it's gonna interpret as a normal beam file. So if you in Erlang right now you make an add function, but you don't export it, and you try to load it, Erl
Yes,
will
but
say
my
function
point
not
is, you're not
used.
trying to. I get that, but you're not trying to load the empty one. You're trying to load plus.
No, we are trying to
That's
load
what
the
I'm not
empty
following.
one, yes. I think
Where?
there's a confusion here. Marinho, could you show?
Well, the empty is called on the plus. No.
Yes, well, look at what Marinho was writing. This is the problem.
Oh, okay. Marinho now actually typed that. So if that's the case, then I understand. But I thought it was being called inside of the plus.
No, we are actually
Okay,
converting
so
your
you're wrapping
query.
the
Yeah,
outside.
it's
Yes,
the
I
other
get it
way
now.
around.
Yeah, because inside of the plus it would be on the same module, so I don't know
And look
why.
at the arguments that Marinho provided. It's the double A's. Why? Because we don't care about the arguments for this case. Right, Marinho?
Right. Uh,
Those A's should be what exactly
They
in that case?
Okay, so it's a little bit confusing because this is artificial. This should not be exposed to the final user of the language. This is only for us. What is this doing? This is when we generate the program, we generate a function for you with arity plus one of the original predicate. So the original predicate of the plus program has only a single uh,
Yes.
uh, yeah, but you need to remember the trick of the preprocessor. Okay, you need to remember that we are actually converting our query to an empty query, and well, a query with an empty name, and making an artificial declaration for you. You need to remember all of those things. Maninho, actually pause what you're doing because apparently it's already working. Could you explain the pipeline just to be completely crystal clear from Magenta because I'm having a hard time explaining it, even though I do have it in my head.
okay, you mean the pipeline of the compiler,
Yeah,
right?
so let's
Until it
start by
eventually.
what happens with this plus that you're highlighting. Show Magenta how this gets converted by the preprocessor first. I think that's more educational.
Okay, so preprocessor, we need to first, that's a query, so we need to convert it
Another query.
um, into another query because the query here could have multiple clauses inside of it, right? We
Yeah,
need to
because
turn
it
it
could be a
into a single
conjunction.
clause. In order to do that, what we do is we make an artificial predicate
Type that down. Type
that
that down.
has. Okay. So we make an artificial predicate. It has an empty name. Um, the arguments are whatever variables are in here, right?
Yeah.
So in this case, it would be these two.
Yeah.
But in the case, why did it had two before?
because before he was asking a single variable. He changed the program. Why I was trying to explain to you. He changed to the plus in query. It was asking what is 4 plus 2 before. Now he's asking what are the possible inputs that the sum is 6.
Right. So what happens is, like, say if we have a query here with multiple clauses. We don't, but let's make one, okay?
Okay.
The body here would also have multiple clauses to maintain the semantics, right?
Mm-hmm.
And if we had another argument here, the arguments of this predicate will have all of the variables here, all of
Yeah,
them.
yeah.
Yeah, so you're basically encapsulating everything, right? That part
And
I understand. That's why you put the A there, because it's just a random
yeah,
atom that you don't care, right?
exactly, exactly. And but the why it's plus 1, right? Because we need the program. Okay, so the
Yeah, you
program that
need
we
not
have.
to conflict. I think I got that too. My question is uh, it's plus one in reference to what? Because in that case there, for example, it's the
Uh,
same arity of the plus.
it's in reference to the arity because not the arity of the plus, but the arity of the query. Okay. So like this query
Oh,
here,
got it,
if
got
we
it,
go
got it,
back
got
to
it.
how it was, it has
Okay,
two
now I
variables,
understand.
right?
Yeah,
Yeah,
Each
yeah, yeah.
variable becomes an argument of this predicate
Mm-hmm.
here.
yes, yes,
Yes, I remember. That's the expansion thingy, right?
yes. So
Okay,
that's going to
now I follow.
become 3 arguments on this version of the plus query because it has 2 variables. So the plus on the compiled version is going to have 3. And why are they bullshit atoms? Because they are all wildcards.
Mm-hmm.
We don't need them. We just need a way to differentiate it. So we are using the
Oh, you
arity
can
just for
pass
that.
wildcards there too, no?
We could.
Actually, we can't.
Oh no, that's a pattern in
Oh,
your
because
language,
yeah, it's a pattern. Exactly.
not a
We
variable.
cannot do that explicitly. But you could just put a bunch of atom news there. Doesn't matter. Okay,
Can put
there's another
trash
thing
as
that
well.
happened during your dinner that we should explain. So, Marinho, could you go to the runtime to explain run lazy to Magita?
Okay.
Garbage marinho, garbage marinho.
Yeah, so Marinho had the idea, which is a very, well, very common sense, but we are not on the level of Marinho apparently, which is to run the query lazily. Why? Because if you don't do that, if you have a bajillion results of what the sums on integers that is equal to true, you're gonna have a problem.
Yeah, this gives us better control whenever we get around to implementing the Karuta REPL. Um,
This
if
is
the query
lazy
had the
string of answers.
yeah, if the query had this take all baked into it, the REPL would be forced to get all of the results for each query, right? We don't want that because there may be potentially infinitely many of them. So instead, we're using this run lazy here as the wrapper of this goal, which is actually the body, which is actually the call to the predicate, right? It's basically this thing here. That's the goal.
Mm-hmm.
So basically, you just call the entry point that's going to construct a goal for you, and you just run. You call it, right? Um, Actually, that's not quite right. It's going to construct a goal that calls the original version with the proper number of arguments and the actual semantics. You know, the query that takes the left hand side and right hand side and just does the calls plus with them with 6 as the third argument, right?
Yeah.
Mm-hmm.
Um,
We should also explain what are we compiling this to. Do you still have it, Marinho? The
it's
full
here.
version with the no 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 no. This is unreadable. I want the one that has the query variable and stuff like that. Do you still have it?
The query variable. You mean tu- 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 tu.
Yeah, that. Actually that. Line 71. So look at that, Mageta. So for each variable on the query that is actually a real variable, we need to do a call with fresh. And
Mm-hmm.
inside that, because each call with fresh gives us the binding on a lambda, which is line 72. And then query variable is the one that maps the logic variable that the lambda gives us to an atom. To an atom.
Yeah,
Uh,
basically this is letting the states know, hey, this variable here is actually part of the query. So at the end, we can do this deref query thingy, which is just unifying the query with,
Yeah, that's the actual unification.
yeah, it's just unifying the query, which is a map, basically,
Yeah. So for example,
with the actual
we
values of the
we
variables.
made it in a way that the binding of the lambda and the binding of the atom have the same string. So that's why you see left-hand side in caps in the right top corner terminal. Because you are defining the query variable as that, and we are also using that as atom. So that's why it is in
Mhm.
single quotes.
Okay.
And
Nice.
this is not being done lazy because he did a take call, and take call is strictifying the thing.
Damn, man, this implementation is already much better than what we had.
Well, it's because we already have a full-blown full
Oh
VM.
yes, yeah, I get it.
We don't have to do memory management. We don't have to take care of the stack and return values and tail calling ourselves. Like, of course it is easier. Um, okay, but this is what? What numbers come up to in naturals to 6, right?
Yeah,
So what do we have? We have 0 plus 6, 1 plus 5, 2 plus 4, 3 plus 3, 4, 2, 6, 5, 1,
five
and
one
6, 0,
and 6 0. Yeah.
which is exactly what we want. So the only thing that is missing is to print that when you run. Oh, but you cannot. This is not a Ah. It would be kind of nice if we could run it for you via the command line, but we can do this for later. I think it's the time for a commit.
Uh, all right, let's do it.
Yeah, but
Now
we're gonna have to
this,
think about it because right now you need to join the repo to have your outcome. It would be kind of nice if we could run it for you as well via the Karuta CLI.
um, yeah, let's just commit this. So we're going to commit this definitely. We're not committing the temp file. We are committing this helper module. Let's commit the plus because that's the new example we're using. Let's format just to make sure I didn't miss anything. And
Yeah, but okay, but this is actually a success. We have 13 minutes to try to run the other examples. It's not gonna be enough time because we're gonna have to implement built-ins now because we don't have negation, we don't have a built-in plus. So
Who
probably
needs
not gonna be able
built-ins?
to finish today. Magetta?
Who needs built-ins?
We do.
It would be nice if we could. Actually, I don't know how that would work. Did we stop to think of how we would call normal Erlang
Yeah, that's
functions?
see, Marin. I told you that
that's
Magetta.
yeah, that's in
Because
the
then,
pipeline. We're not there
because
yet.
then the language is actually useful, right? We can print stuff. Well, we can see this data structure, but that's not the same as printing, right?
Well, the problem with that is that we're gonna have to think about, okay, are we gonna go with the Prolog route or the Mercury route? Because the Mercury route has actually another system, which is the, what did you call, Marinho? Linearity?
Yeah, we need linear types basically.
In order to do it.
Which will not going to happen. So
Okay, so we're
I
gonna do the
think we
Prolog way,
better
which is to allow you to have
just wrap it
a
from.
back door to go to like imperative world or something.
Um, that's a bit more difficult in Kangen because the order of things is less well defined. Unless we want to change the definition of disjunction to be ordered.
I think.
I thought we would go with the Mercury route. I'm surprised Magetta doesn't want it.
It's not that I don't want it. I just think it will be. Well, is it that hard? Let me see.
Yes, but it doesn't
Because
matter. We have Marin.
I wouldn't abuse of that. Just saying.
It doesn't matter
I
at
wouldn't
all.
abuse. Alright. Um, do we actually need all of the like we don't need a full-blown type system, right? Like a linear type system. I don't think we need all of that. We probably just need to track the state in a linear string, which is already hard, but I think it's less hard than actually implementing a
No, I
well,
actually was joking. I don't know how hard it is, actually.
I don't think it is easy. And
Marinho.
by the way, we're making all of these decisions without even thinking of concurrency. So
No, no,
I
no.
think this
Actually, we are thinking of concurrency, because here's the
Um,
thing. I was talking to Mageta,
with neutral current, I don't think we have much of an issue with that though. Uh, but if we get outside of that and like for linear, I think we might.
Oh, okay. You
So
mean that linear type system
yeah,
interfere with
right now
concurrency?
I don't think we do. Given what
uh,
I
I
saw in the
think
paper.
I think you were maybe thinking about concurrency at the wrong level because here's the thing. We wrote the kernel runtime in the microkernel style, which is monadic, right?
Yeah.
And for that to work properly, we need structural sharing, which means it needs to run into a single process, which means that actually we shouldn't be thinking about concurrency as we have in threads, but we should think about it in terms of spawning other processes that are also single threaded, but
Fork.
we have
Right.
message passing. Yeah,
I see.
basically, let's just
Okay.
borrow
No,
Erlang's concurrency
you
model.
didn't mean like yeah. I see. You didn't mean like forking the structure. Well, that could be as well, but just using of the Erlang model
No, 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 no.
to
I
spawn a
was
new.
talking about forking the structure because apparently, and this is allegedly, there is a thing called C coding, which implements constraint-based coding and not relational coding. And
But
according to
that's
the
not
book,
concurrent yet. It's just constraint based.
exactly, exactly. But that facility,
Send me
my
that paper.
understanding of reading the book club book is that if you have constraint coding and encapsulated environment, you have all the pieces to have a good concurrency in a logic language. Am I
The
wrong here?
problem is that, yes, we can try to do that. The problem is that no matter what we go with, we have the issue of, okay, we spawned a bean process, but that means if we share the data between the processes, they will not actually physically share structure anymore, which we kind of want.
What do you mean they will not physically share structure anymore in this case?
Because the data is isolated per process, right?
So you need to copy parts of it essentially, right? Just
Ah,
to
the copy problem. Always the copy problem.
yeah.
Sure.
Which is I think a price to pay for like full isolation.
Yeah, pretty much. Okay, so Marinho, the last thing I want to do today before we finish, we have 7 minutes-ish. Let's implement the foundation for built-ins because I think the equals is like hard-coded in there. We should have a
It
proper
kind
way
of
to
is.
extend that. So I was kind of thinking of an ADT just for built-ins.
Oh, like we had before?
Yeah, because right now the
I mean, we can do
equals
that.
is a special case. We have an if just for it, right? But we should actually have a pattern match on it. And then if what you have pattern matches this, I don't know, to string of a particular built-in, we need to treat you separately. You cannot just do the normal line 97 process. We need to do something special. That's kind of what I was thinking. What do you think about this approach?
Uh, I mean, we can just do it here, I guess. Like case, actually not case, this is
No, 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 no.
OCaml. So
We should
match.
no, 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 no. We should go to the. We should create a module called built-ins inside the Beam directory. That you're going to have a type T there. That's going to be all of the built-ins. Net equals plus, and then we're going to put all the functions that, oh, how is going to be the bin compilation of this? How's going to be the arity of this? All of those details should live in a separate module, and we just call the function here to not pollute the compilation. Because we're going to have many of them, right?
Are we?
I believe so. Like, let's count.
Yeah, we probably
Net,
are.
int, equal, plus, negation, less equals,
Yeah, we're probably gonna have
multiplication.
quite a bit of them.
Yeah, so I would put in a separate module completely, and then it would make, I don't know, built-in.ml inside the beam thing.
Okay. Beam, lib, beam, built in.ml.
And then type T, which is gonna be an ADT with like the tags equal, off, the two things, right? So left hand side and right hand side, and then you keep going with that. I was thinking of doing like that. I don't know if it's a good idea or not.
It probably isn't actually, because here's the thing: we're reading an AST, right?
Yeah.
Like here, we're reading one of these basically.
Yeah,
Clause
keep
keys
in mind that
basically.
we're gonna have to clean this up, right? You notice this yourself that this EST that we originally made for the Warren's VM is not suitable anymore because it has a lot of fluff that we don't care because of how we're doing for the to the beam.
It's probably better actually to add the AST, the built-ins here, and do the conversion in the preprocessor, probably.
Do the conversion on the preprocessor. I don't understand what you mean. The preprocessor spells clauses. They don't spell. The preprocessor doesn't know about the beam stuff. Only the compiler does.
It doesn't need to.
Okay, but what are you proposing then? I don't get it.
Um, like, okay, we have expressions, right? Um, actually, where is it? Declarations is a decal.
Yeah, the built-ins are being uh, obscured by being decals, right? We don't know at the level of the parser if they are built-ins or not.
I'm proposing that maybe we should actually.
Oh, so you want to make the parser smarter to know about built-ins.
Um, yeah, because basically, like, the body of a declaration right now is a list of functors, right?
Yeah.
And a functor doesn't tell us if it's a built-in or not. I'm
How do
thinking,
you plan on identifying that? Because I'm against adding syntax for it.
no, it's not about
Uh,
syntax. It's about if you look at a functor and it has a particular name and arity, then we can convert that to an actual built-in node, kind of like, I don't know, type built-in equals, and then we do EQ of, and this needs to be
What is the
recursive actually.
benefit of do? Okay, I have two questions. So what is the benefit of doing that in comparison to doing the preprocessor itself? Because the preprocessor is already inspecting everything. Why we cannot just do in the preprocessor the identification? And
That's
second,
what I'm proposing actually, because we
oh, so you're not proposing the parser to be smarter, but the preprocessor to be smarter.
yeah, because we have a bunch of not we're not touching the parser clause because we're not changing the syntax, the surface syntax, but we do want to change the shape of the AST, no?
Yeah, but I thought we would not
So
change the AST right now because that's gonna be a whole overall, right? We're gonna have to break a bunch of stuff.
yeah, we're gonna have to do a bunch of stuff,
Yeah, that's like the next PR. Okay, so
basically.
your proposal is to add a node that the preprocessor will be able to identify if it's a built-in or not. And then we treat this, and then the compiler doesn't have to do the identification itself. It's just gonna be like pattern matching. Oh, you're a built-in. Okay.
Yeah, basically the idea is the preprocessor will go inside of the body of each declaration and of the query, I guess. And if it finds a functor that actually names a built-in, we just say, okay, instead of encoding it as a functor, we're gonna have a different node type here called built-in. which is going to be like EQ of uh, expert expert or whatever, right? And we just do
Oh.
this replacing of this to this inside of the preprocessor.
Okay, but what are the types of the experts? Are they beam experts, or are we gonna are they like line six?
They are line 6 experts.
Okay, so okay, okay, that's not that bad. Yeah, that's not that bad actually. So your proposal is to basically make a type that is able to be a functor and a built-in at the same time, and then swap on line 26.
Swap on line 26. So yeah, basically. Basically.
Um, I think that's okay, but there's something else. We should not allow you to redeclare it. So if you have a declaration of equals and it's equal with arity true, we should have a preprocessor error then. Correct?
Right now, that is correct. When we add modules, we'll have to revisit that, actually.
Yeah, but when we put modules, it's going to be like a completely separate conversation. Because that's going to put things upside down. We're going to have like problems of all sorts of natures at that time. I think we could do, let's just do the equals for now then. Just to see if the concept works. What do you think?
Uh,
I can do the other ones manually myself after we have the foundation. It's okay.
okay, let's see. And built-in equals EQ of expert. We derive this.
Yeah, but how are you? You need another type now to combine them, right? Decal body maybe?
Um, let's use the proper nomenclature, okay? Let's call it a goal.
Oh, using the Kari nomenclature. I see. Sure.
Um, kind of like this, right?
Yes, exactly. Yeah, that's gonna break the shit out of everything. Wait, don't we have to teach the parser how to parse it now? I'm confused. How? Why did the first thing that broke was the preprocessor?
Because we didn't touch the parser clauses.
Ah, that's true. The parser okay, I'm actually glad we did that way then.
Rename declaration. Why is the first thing to break this?
Because this is expecting a declaration to be structured with a body being a functor, and now we broke that hypothesis.
Okay, so fold right, zero body. What are we doing? For
You
each
need to pattern
body,
match. You need to grab the body and pattern match before doing whatever you're currently doing.
rename arg. Because of this,
Yeah,
no?
the problem is line 19. Line 19, you are passing a body as the initial accumulator, but that's not going to make sense because the body is now can be a custom or a built-in. You need to pattern match on the body before doing this fold right.
No, because the body is a list.
It's a list of goals, right?
It's a list of goals. Which means actually the problem is up here. I think. Is it?
I'm not so sure. Oh no, it is. It is because you are doing the cones on line 18 with the body prime. Yeah, but now that doesn't. You need to put a custom or a built-in uh, wrapped around the content. No, it's after the equals of the content. You need to put custom or
After
built-in
the
there.
equals.
Yeah, that needs to have a
This
tag.
is
This is a built-in, so you should
actually
put a built-in there.
actually yeah, we should just put a built-in here, I guess.
Yeah, but
Uh,
what is the value that you put it? Oh, equals. That makes complete sense. New var. Don't forget the parentheses and the comma. And then you nuke everything else. There's something
and
else
in
wrong. Oh, I know what's
fact,
wrong. You discarded the location. No, 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 you didn't. You did the with location with the goal, so it's correct. Next year, compiler time. Okay, preprocessor line 43. What is that?
um, wait, the parser.
Oh, now the parser broke.
Hmm. Line 58. 58.
Ah,
This
makes
is a
sense.
declaration.
The body cannot just be a bunch of statements now. You need to put something in there.
This is a maybe functor.
Ah, I know the problem. We changed deco, man. Deco is also used by the parser. We should not have changed that. Deco is used
Hmm.
by line 16 and by the clauses themselves.
That's kind of annoying, actually.
Well, back in the day it was cool because we could reuse it for both compiler clauses and parser clauses. But now it's annoying because they are different internally.
Hmm. Should we maybe actually do this in the parser then already,
Well,
since we
that's
can?
well, I don't like the idea of making the parser smart, to be honest. I like it to make it dumb. Um, but well, you were the guy that likes a single pass everything. Not even the parsing, but everything.
Hmm.
Mageto, you have opinions about this?
Sorry, replying Benet. What's that?
Okay, so here's the situation. We changed. No, please don't do that, Marinho. We changed line 32. We changed the body of declarations. So instead of being a functor, it's now a goal. And a goal
Okay.
can be on line 30, a built-in or a custom. Custom is what the programmer writes. So you're doing a declaration where the body is a bunch of functors, a list of functors. We want to introduce a distinction that you can be using a built-in of Karuta. So
Got it.
equals, plus, multiplication, all of that stuff. But the
Mhm.
problem is that we changed line 32 that is also used by the parser. And the parser doesn't have context to identify if you're actually using a built-in or a
Right.
custom.
Is it a beauty? Why? First of all, why do we need the difference there? Like, do we need to treat them differently
Yes. Well,
somehow?
we need to treat them differently. Marinho proposed to do the differentiation of the preprocessor. The preprocessor will have a way to say, oh,
Yeah,
equals
like you
is a
have a
built-in.
symbol table, right? And then you
Exactly,
can look
exactly,
up.
exactly. Pretty much the idea. But here's the problem. Line 16, that's what the parser understands, and that's using a decal. Line 9, that's what the preprocessor understands, and that's also using a decal. The preprocessor is fine, because the preprocessor will be the one to identify if it's a built-in or a custom. But the parser is also using a decal, and then how do you solve it? You either make a copy of a decal just for the parser using normal functors, or you make the
Ah,
parser smarter to do the
which
lookup table
is
in the parser.
yeah.
And I don't like, okay, but here's the situation. I don't like making parsers
Mm.
smart. But Marinho is the guy that his language will do everything in a single pass.
I've been rethinking that lately, by the way.
Have you changed your mind?
Um,
No. That's the short
the,
answer to no.
I have actually, because here's the thing: I don't want the parser to be able to execute arbitrary codes, and it's kind of hard to not do that if you do everything in the reader.
Yeah, so I want your opinion, Mageta, because Marinho is biased and I'm also biased. What's your take on it?
Oh, my, I don't think you answered still one of the questions, or I didn't get it, which is
Ask the question again.
why do we need the difference between the, like, specifically on the, can you go up, Marinho? Where
Uh,
was the built-in custom
Line
Here.
30.
object? Yeah, there. So why do we need that distinction on the Go specifically?
Because if you are a built-in, we need to compile you differently.
How so?
Show the equals on screen, please, Marinho. The
Uh,
runtime equals.
I
Because
guess
like,
we can just look at this because we're doing this now.
Yeah. So here's the thing. If you're doing an equals, that has a special that needs to be specially constructed using microcutting.
because of an
Um,
arbitrary, no.
Actually, theoretically, we don't really need to distinguish built-ins if we have modules, because then the actual distinction
Yes,
is between what's local and what's not local, you see?
yes, that's what I was thinking. Like, if I mean, I don't know the internals, but my original thought would be, okay, we just make a standard library as an extension, and then you just prefix the program, every program with that standard library. So why would you need the?
Because the reason you need to treat that specially, Magit, is because these microcutting equals is not what would be we would be compiling. It is specially constructed. It is
Yeah, where
not.
we need to call this function
And
basically.
if you compile, if you use our compiler without that if that Marinho just showed, treating the equals specially, we would not get this result out of the equals. Equals has special semantics. And the same thing applies for naturals, I believe, right? We also have the examples of doing the naturals.
Yeah, as soon as we start implementing a standard library, we're gonna have to recognize everything that's in there, basically.
Yeah, but I don't quite get what you said. You
So
said that if we have modules, then you don't need the differentiation anymore. I don't understand that.
No, no,
How
no.
does that work?
It's not that we don't need the differentiation. It's that we don't need to differentiate built-ins specifically because that can just be a module of built-ins. And then the real question is, okay, what's local and what's from another module? You see?
I don't see. Because if you're using equals from the prelude module, let's say, you still have to compile it in a very particular way. You cannot just compile it normally as a normal predicate. Am I wrong?
Um, well, this is, as far as the compiler is concerned, this is a normal predicate. It's just that it's in a different place. You see?
But we are compiling it in a completely different way, Marinho. That's my point. Like, how are we compiling this? We are not. We are just informing the OCaml that, hey, you have access to an equals of arity2. Use it. We're not even compiling the equals. You're just doing calls to equals because we are assuming that we're going to spawn the REPL with the Karuta runtime, which has microcutting inside. Right? Is that right?
Yeah, this is the difference. If we're calling something that's a built-in or in the standard library or whatever, we need to prefix this with this module name, you see?
Yes, but
Otherwise, we
we're
just
not
do a local
compiling it
call.
as well. You see, we're not. Do you agree? We're not compiling equals. We're just calling equals. Agree?
We are just calling equals, yes.
Yeah. So that's what I mean. We are treating built-ins in a very particularly different way, which is not compiling them at all, just doing calls.
That's true of whatever predicates are not defined in the same file, though.
Ah, that's what you meant by being separate modules. Because if it was in a separate module, regardless if it's built-in or not, we would do the same treatment, right?
Yeah, exactly.
That's what I now I see. Now I see. Okay. Um,
But just one thing, that would just be the case for a few symbols, right? Not the whole standard library. That's my point.
not the well. We hope, but last
Yeah,
time we did
so
this,
why not make a distinction between that's not really true, okay, but a third category, like special form, that you just extend on a goal. So we have a because man, it doesn't really make sense to make a distinction like custom and built-in. Like built-in is more like a
it's a primitive.
it's I would say it's more like a macro, right? It's closer to that than a or a well, I
Not
guess that's what I
not
meant with
really. EQ is exactly it has exactly the same behavior as a predicate, a normal predicate. It just happens to be part of the runtime because this is basically just unification,
Unification.
right?
Yeah, so if you just compile EQ as a predicate, you compile. You're not going to generate this. Unify.
well, but my point is that there's a difference between the predicate at a higher level, which is whatever the user can produce, and the
Yes,
mechanism for unification, right?
sure.
So why would you need to expose the mechanism for unification at the higher level, the EQ, I mean, as a predicate?
Because of our compilation strategy, we can't just use pattern matching at the Erlang level, which means we have to whatever pattern matching the user is doing in the arguments of the predicates needs to be pushed down to the body, and we need a way to access that from the as a compilation target. And the easiest way to do that is just say, okay, EQ is a predicate now.
I now understand the problem.
Yeah, but here's the solution. If what Marinho said is right, we can just skip this problem and like ignore it and just go with to solve modules, and then we solve two
Well,
birds in a single with a single
yes,
stone.
I think it will just be a problem for specifically EQ. I don't see that for anything else if we, well, control ourselves, right? I don't think it's an issue.
No, no, no. That will not work for naturals, for example. Net, int, they need to be built-ins. Well, they were built-ins back in the original version of Karuta.
Well, yeah, some things need to be built in. Like, for instance, if we need to call an Erlang predicate to implement the Karuta predicate, like isInt, for instance, right? Um,
We cannot rely on like the programmer does not have a way to express that properly, right?
yeah, we either go to implement FFI or we make them like opaque built-ins that we just rely on,
Which is what we did the first time.
which is what we did the first time, yes.
Okay, but uh, I don't want to spend a lot of time implementing something that when we put modules we're gonna have to delete. I don't want that. So, so
Mm, well, in that case, we can just take the shortcut and do what Magetta said. Instead of having the standard library as a separate file, um, we just concatenate it whenever we compile a Beam module, essentially.
well, but I thought we would do that anyway. That was always in my
Um,
head that would need to be done.
that only really needs to be done if we don't have a proper module system, which we don't yet.
No, but let's
It should
assume
be a
we do.
challenge.
That doesn't solve how net is implemented, right? My
It does
problem.
because
Go on.
if you say, okay, I have a bunch of built-ins, but they are isolated in a module, I can just compile calls to the module, and then the module doesn't have to be compiled by the Karuta compiler. It can just be a normal
Yeah,
bin file.
that's it's literally just a bean, and then you just
But
import.
you
Yeah,
have to
that's
identify them anyway, Marinho. Because if you are compiling and you see net, instead of doing what we currently do, we have to
No,
just do a
because if
call with
it's
module.
no, because if it's isolated in a module at the Karuta level, it's going to have a prefix. No,
Oh, so you mean like treat it as if you are writing Karuta, but you assume there is a module that gives you the built-ins.
Yeah, we can just have a module for like numerics or whatever, numbers, math, whatever you want to call it. And that would be inside of
Ah,
that. And the user
ah,
doesn't have to know that it's not actually written in Karuta, you see?
Yep,
ah.
that's I approve of that.
Okay, so that means that we can literally not do anything else. Go to the module system. Oh, but there's a trade-off there. That means we cannot run any more examples, folks.
What? Oh, because of the nets and etc. They
Yeah,
are all used,
yeah.
right? Well, we can add the net as a palliative because it will take a while for modules to get working, I think.
Well, we thought it would take a while to compile. We are done. We compiled.
Let's brainstorm here. Okay, let's think about that before. How much time do we have streaming already on this?
2 hours, past 2 hours already.
I should probably cut it already then.
No, yeah, I'm gonna stop the recording.